All right, welcome. Today we're going to cover section 5.1 and 5.2. I will keep some things brief, but I will tell you this, if you don't recall a lot of the material that I mentioned that you might recall from Algebra 2, it would probably be a good idea to brush up on those skills. 5.1 is going to essentially remind you about the unit circle, so you should have learned about it in Algebra 2. And I'm going to go at it from that lens rather than going into great detail on the construction of the unit circle. Okay, so you're going to understand how to design it, how to visualize the angles and reference numbers on it. And I would say if you can't recall this, this is what I would spend some time on. So the unit circle, very quick reminder, it all stems from your special right triangles. So I have two pictures here of your 30, 60, 90 and your 45, 45, 90, which you studied in geometry, and then again when you constructed the unit circle. So if you don't recall this at all, I would maybe jot down these pieces so you can refer to it if needed later. But notice your 30, 60, 90, for example. Opposite of your smallest angle is your smallest side. Opposite of your middle angle is your middle length side. And opposite of your 90 biggest angle is your biggest side. So just kind of reminding you where those stem from. Same goes with the 45, 45. Those ratios are 1, 1, and square root of 2. So on the unit circle, first of all, the unit circle, just reminding you, has a radius of 1. So anywhere I go on the circle, clearly I'm going to have a radius of 1. So if you look at this picture right here, I kind of slid in the 30, 60, 90 triangle. Well, the radius is supposed to be 1, and clearly on your geometric triangles put into unit circle, it's not 1, right? It's 2. So the issue is taking this triangle from what you know, taking the ratios, and now we have to make this length of 2 over here, we have to change it to 1 to put it into the unit circle. So easy fix, divide it by 2, right? If I divide this by 2, that's going to be 1. Well, then I have to divide all of the other ratios by 2 to balance that out as well. So in construction, it would look like that. Okay, so now on the unit circle, if I said, what is the sine of 30 degrees? If you recall SOHCAHTOA, actually while I'm here, if you don't recall SOHCAHTOA, you should probably write that down as well. So sine, cosine, tangent, and then the opposite and adjacent and hypotenuse pieces that go with it. So if I asked you what is the sine of 30 degrees, for example, according to my unit circle, I can, so this triangle right here now is a 30-degree angle, and I know that sine ratio is opposite over hypotenuse, so opposite is 1/2 and hypotenuse is 1, and 1/2 over 1 is clearly 1/2. Okay, now the good news is if you didn't derive this from the unit circle, I could go back over here and use my regular geometry triangle as well. So if I said sine of 30 is opposite, which is 1, over hypotenuse, which is 2, and I still get 1/2. Okay, but I would highly encourage you to go away from your geometric triangles, like as soon as you possibly can. So going with the blue triangle here in terms of the unit circle. Okay, same thing, and I'm going to go through this one a little more quickly, but if I pull my 45, 45, 90 onto the unit circle, so you can see my 45 degree, and I have my ratios there, but again on the unit circle, the radius needs to be 1. So to fix this problem, because my radius is currently the square root of 2, I need to divide by the square root of 2, which means to balance, I have to divide all of my sides by the square root of 2. Okay, and you probably also need to recall that in order to rationalize those denominators, because you don't want to divide by a square root, a radical, I need to multiply the top and the bottom by the square root of 2 over the square root of 2, which is then going to give me this green triangle here. Okay, and these are my unit circle pieces. So take note of my radius is now 1, that's great. My other 2 sides, which are going to be sine and cosine values, are square root of 2 over 2. Okay, and I'm just going through these kind of quickly. Last but not least, 30, 60, 90. Again, on a unit circle, I need the radius to be 1. So right now it's 2. To fix that, I divide everything by 2. Easy fix, easy fix, easy fix. And in that summary, you can see in the blue triangle would be my unit circle ratios for the 30, 60, 90. Okay, again, taking note, the radius is now 1, which is what I want. And my lengths are square root of 3 over 2 and 1/2, which are going to be my cosine and sine values. Okay, so now I'm going to put this all together. Here is your completed unit circle, which again, you spent some quality time on in Algebra 2. It is going to seem overwhelming right now because you might not remember a whole lot about it. Study this, spend some time on it, derive the pieces. Things aren't going to get easier for you if you put this off. So that should be priority. But if you look at the unit circle, if you look at your 30, 60, and 90, or sorry, 30, 45, and 60 degrees, which I just talked about their triangle pieces, notice the coordinates over here, square root of 3 over 2, comma 1/2. The coordinates at the 45, square root of 2 over 2, square root of 2 over 2. These should be familiar, right? They all come from that special right triangle. 60 degree coordinates as well are just opposite of your 30 degree, right? That should probably make sense because the 30 and 60 degree triangles share sides. So that being said, those key pieces that I have underlined in red, those are your cosine and sine values for that particular degree angle. So 30 degrees, for example, has a cosine value of square root of 3 over 2, and it has a sine value of 1/2. Okay, so rather than constructing the triangles, you can just refamiliarize, possibly memorize those again. What it's measuring, of course, is the lengths, the ratio lengths of your unit circle. So if I know that the radius is 1, then to get to this point right here, I know the cosine will be the length of the square root of 3 over 2, and the sine will be the length of 1/2. So that's really what you're finding is those distances. So it probably makes sense when I go to the 60 degree angle from my origin. To get to this point, I'm going over, which is cosine, a much shorter distance, and going up sine a longer distance, right? So the blue horizontal length is the same as the green vertical length. You can probably visually see that, even though mine is, not perfect. So just to summarize, since I keep referring to this, your cosine of any angle is going to be the x-coordinate, sine of the angle is going to be the y-coordinate, and then tangent, which we'll get into more detail later, but you'll want to make note of that as well. The tangent ratio is y divided by x, or sine divided by cosine, if you prefer. Okay, other things to notice on the unit circle is the reflective properties. So if I go over here to 120 degrees, notice that 120 degrees, the coordinates are the same as the coordinates of the 60 degree angle, except for the x or cosine is negated, which makes sense because you're going into the second quadrant. Okay, note when you get into the third quadrant, all of the sine and cosine values are negative, which makes sense. X, y, cosine, sine, everything is negative in quadrant 3. Quadrant 4, notice only the y coordinates or sine values are negated. Okay, so things that you're going to need to kind of refresh your memory on. The other thing that you're going to need to, remind yourself of is how to get the angles in radians. Okay, so I'm going to erase all of my stuff here so you can look back at the unit circle. And maybe take a screenshot of this unit circle or just Google unit circle and you'll have ample pictures to look at. But on this unit circle, the 30 degree in radians, and I know it's kind of little, you need to zoom in, but the 30 degree angle in radians is pi over 6. Okay, you will need to know both of those, degrees and radians. That being said, if I reflect over the y-axis, the 150 degree angle has a radians of 5 pi over 6. Notice both radians are in terms of sixths, right? 1, 6, 5, 6. Go down in the third quadrant where 210 is going to have the same coordinates, right? All of these coordinates here are the same, just the plus and minuses change. And notice its angle in radians is 7 pi over 6. Okay, and lastly, in the fourth quadrant, at 330 degrees, notice its radians is 11 pi over 6. So all of the angles that reference the 30 degrees in all four quadrants have radians that are sixth. So 1, 6, 5, 6, 7, 6, 11, 6. And again, you'll want to be familiar with that. Okay, the rest of them I'll go through just quickly, but you can also note that the thirds, so 60-degree angle in radians is pi over 3. Okay, well then 120 degrees is 2 pi over 3. They're all thirds. So then I will scroll down so you can see that. 240 degrees is 4 pi over 3. So another third. And last but not least, in the fourth quadrant, 300 degrees is 5 pi over 3. So those are all thirds. And then the fourths are the same. So the 45 degree is pi over 4, 135 is 3 pi over 4, 225 is 5 pi over 4, and 315 degrees is 7 pi over 4. Okay, all it is fractions. So if you want to think about it, because you're also going to have to know the quadrantal angles, like the 0 degrees, the 90 degrees, the 180 degrees, the 270, you can just break this unit circle into sixths and fourths, and you'll get everything. Okay, so I'm going to erase all my colors here again and just kind of show you that quickly, and then we're going to need to move on beyond this. Okay, so if I start here at my unit circle, this is 1/6 of pi. Okay, and I probably should reference pi is over here. So pi is the radian measure, equivalency to 180 degrees. So if I start here, this is 1/6. Okay, then if I break it into 2/6, well, what is 2/6? 2/6 reduce is 1/3, right? So I got pi over 6, pi over 3, so there's 1/6, 2/6, 3/6 would be right here. 3/6 is pi over 2 reduced. 4/6 would be this sliver, and 4/6 reduced is 2 pi over 3. 5/6 right here, and 5/6 doesn't reduce, and then of course 6/6 I'm to pi, right? And 6/6 is pi. And then you can keep going, and I'm not going to keep writing these all out, but this would be 7/6, and the next one would be 8/6, which reduces to 4/3, and 9/6, which reduces to 3/2, and 10/6, which reduces to 5/3, and 11/6. Okay, now you have every radian measure on the unit circle except the fourths, but those are pretty easy. So if I highlight those in blue, this is 1/4, 2/4 overlaps, 3/4, and 4/4 overlaps, 5/4, 6/4 overlap, and 7/4 and 8/4, you're to 2 pi. So if you recall, the unit circle full rotation is 2 pi radians. Okay, now there are other videos out there if you need more background on the unit circle, but we're gonna move on and do a whole bunch of stuff with it. So the first thing you have to recall is probably what you call the reference angle in Algebra 2. In your pre-calc book, it's called a reference number. It's the same thing. Okay, so reference number, first and foremost, notation, is T with a bar above it. Okay, so a reference number is the shortest distance between the terminal point of the angle and the x-axis. Okay, you need to know that, and then I'm going to clearly give you some examples. So the shortest distance from the terminal point of the angle and the x-axis. Okay, so for example, if you have 4/3 pi, okay, so T is 4/3 pi. This right here is your angle. Okay, so first thing you probably want to do is visualize it, and how I do this is I look at the if it's a degree in radians, I look at the denominator. Since it's a third, I know that pi is going to also be a third, so I would just make that 3/3. Okay, well, if you visualize when you draw an angle, you always start at the x-axis and then you go counterclockwise. So if I go all the way to 3/3 and then another 1/3, that would bring me to 4/3 pi. Okay, so this angle, if I draw it in right here, that angle is 4/3 pi. Okay, That's not what the question is asking, however. It's asking for the reference number. Okay, so now the reference number is the shortest distance from the terminal side to the x-axis. Okay, so the red is my terminal side. The x-axis, I could go this way or I could go this way. By definition, it's the shortest side. Okay, so I don't want this one here, so I will erase it. So the shortest side from the terminal side of the angle to the x-axis. What does that measure? Well, if you think about what I said verbally as I was drawing the angle, I go all the way around, I hit 3/3, and then another 1/3 is gonna bring me to 4/3. That another 1/3 right there, that's my blue reference angle. So T with a bar above it, reference angle, is 1/3 pi, or pi over 3, however you want to write that, probably pi over 3. Okay, so again, if you think about the black angle is 3/3 pi, plus another 1/3, your reference, brings you to your angle of 4/3. Okay, let's look at another one. So what if your angle is negative 7/6 pi? Okay, so negative is gonna go clockwise now, so go the opposite direction. And my angle is a 1/6, so my pi is now gonna be 6/6, but it's also negative because I'm going clockwise, right? So if I start at my x-axis, and then I'm gonna go around 6/6 pi, negative 6/6 pi, I should say, so that's negative pi. To get to 7/6, I would have to go one more 6 beyond. So again, if I draw this entire angle, this angle here is negative 7/6 pi. Okay, so what do I reference? The shortest distance from the terminal side of my angle to the x-axis. Clearly not gonna be this because that's not the shorter distance. So from the end of your angle, this red line, to the x-axis. So what does that measure? Well, if this whole thing is 7/6, and this angle over here is 6/6, the leftover extra is 1 more 1/6. So T bar, reference number, is pi over 6. Now, something else you want to know, reference angles are never, never negative. So even though you're going in the negative direction clockwise, reference angles are always positive. All right, maybe pause the video and try these. See how you're feeling about this. Okay, I'm gonna talk through these a little more quickly, assuming that you've paused the video and spent a little time on that. So your angle is 14/5. So again, my pi now is gonna be fifths. So I'm gonna make that 5/5. All the way around 2 pi would be 10/5. Okay, so I'm gonna go to 14/5. So if I go all the way around, that's 10/5. Plus another 2.5 would bring me to 12.5/5. All the way to 14/5. Okay, so let me just change this. This would be 15/5. So if I keep adding 5/5, like every increment of pi is another 5/5. So I'll show you with my red pen again. This all the way around is 10/5. Plus another 4 would be 14/5 pi. That red angle kind of shows the path of that. So what is it referencing? Well, again, from my terminal side to the x-axis, that's this sliver. So if my red angle is 14/5, how many more to get to the x-axis to get to 15/5? Well, 15/5 minus 14/5 is 1/5. So that reference angle is pi over 5. Okay, the last one, T is 2.5. And that one's unique because there's no pi in it. But it's not degrees because there's also no degree symbol, so please don't confuse that. But 2.5, well, I know if this is pi, I'm just going to write 3.14 because we know that that's pi. So 2.5, if I were to approximate that, is a little before 3.14. Okay, so there's my angle. Well, my reference angle is from my terminal side to the x-axis. So mathematically, how can I figure out what T bar, my reference number, is? I can take 3.14 minus 2.5 and get that as an approximation, or if I want it exact, I can take pi, 3.14 is pi, minus 2.5. And probably in WebAssign, they're looking for this exact answer. Obviously, if you approximated it on a test or something, that would be fine with me, but for WebAssign, I would stick with exact values there, but just to kind of understand numerically what you just found. Okay, one thing I guess I didn't cover is what if you have an angle that's in degrees. So for example, if your angle is 70 degrees, okay, well this is 180, this is 90. So if you were going to approximate, no, I don't want to make this 70, that's no fun. Let's just make it 110 degrees. Okay, so if I visualize the angle, well if this is 90 plus another 20 would bring me to 110 degrees, okay? And if you think about as you're drawing the angle, I just said the reference angle. I said this is 90 plus another 20. I'm sorry, that's not the reference angle, but that would give me the 110. So now the remaining to get to 180 is my reference angle. Okay, so again, if this is 110, how much more to get to 180? Well, of course, you can obviously do the math as well. So 180 minus 110, and that reference angle, reference number, reference angle, same thing, is going to be 70 degrees. So there, it's the same way in degrees. All right, on to a little bit more with the unit circle. I did not reference the equation probably to the unit circle, but you should be familiar with the equation of a circle in general. So x squared plus y squared equals 1, specifically for the unit circle, because if you recall, that 1 will give you a radius of 1. So if you're asked to show that a point is on the unit circle, you just need to prove mathematically that x squared plus y squared equals 1. So if this is the point, x and y, then you are, like I said, you're just proving that math right there. So square root of 11 over 6 squared, x squared plus y squared equals 1. And then I'm guessing you can handle the math, but squaring everything inside the parentheses, so that will be 11 over 36 plus 25 over 36. And does that equal 1? Yes, because this is 36 over 36. Which obviously is 1. So I just showed, yes, that is on the unit circle. Okay, so pretty basic. You might have to work a few things backwards, so you might have to find a missing coordinate given some information about the unit circle. So we are going to figure out what the x coordinate is. Please note that you're in the 4th quadrant, and in the 4th quadrant, x is positive and y is negative. So okay, I'll come back to that. You're probably like, yep, duh, got it. If I use x squared plus y squared equals 1, y squared, so I will just plug this in, equals 1, right? So plugging in the coordinates and squaring everything, you get 49 over 625. Okay, and then it's a little bit of algebra. So I'm going to subtract over the 49 over 625, and common denominator says that 1 would be 625 over 625, and when you subtract those, let's see, 625 minus 49, that'd be 576, and then to solve for x you would square root. Again, I'm just kind of going through the algebra quickly, assuming you're okay with this. Technically, this is going to be plus or minus, let's see, the square root of 576 is 24, square root of 625 is 25. Now I have to make my decision on the plus or minus based on the quadrant that I'm in. Just always pay attention to quadrants, such a big deal in this chapter. So because I'm in the 4th quadrant, right, then I know that my x coordinate is positive and not negative there. So there I have the other missing x coordinate. So 24 25ths. All right, moving on to 5.2. I kind of mentioned this is a big day. But 5.2 is just more extensions on the unit circle. Okay, so you're going to learn about your reciprocal trig, functions and other relationships between those values on the unit circle. So if you don't recall, we've already covered the sine, cosine, and tangent ratios. So you know that your sine on the unit circle, your sine of any angle is equal to the y coordinate. Cosine of any angle is your x coordinate, and the tangent is your y divided by your x. Okay, now cosecant, depending on your previous math class, your exposure to these will vary. That's how you read CSC is cosecant, is always the reciprocal of sine. Okay, so these reciprocal one another. So if you know the sine is y, you know the cosecant is 1 divided by y, reciprocals. Okay, on that same note, SEC, which is pronounced secant, is reciprocal with the cosine value. So if you know cosine is x, your secant is 1 divided by x. And as you can imagine, COT, which is cotangent, that's the only logical name here, is the reciprocal of the tangent. So if you know tangent is y over x, then you know cotangent is x over y. You need to know those, okay? So what will you use those for? Here's an example, okay, and I kind of answered the first question, but given the point negative 12/13 and 5/13 is the point on the unit circle. Okay, well you would show that x squared plus y squared equals 1. Yes, it is. I'm going to skip that part because we just did that. I'm going to ask you to find all of the 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent. Okay, so knowing this coordinate, normally I would say coordinate is x, y. You should get comfortable with, instead of x, y, cosine, sine. Cosine is your x coordinate, sine is your y coordinate. So I know that the sine is 5/13, like I've got a freebie, and the cosine is negative 12/13, another freebie, right? Like I know my cosine and sine values for this particular angle. By the way, I don't know what the angle is. Okay, then if you know that sine and cosecant are reciprocals of one another, then I know cosecant is literally just the reciprocal of the sine. So 5/13 becomes 13/5. Secant is the reciprocal of cosine, so it becomes negative 13/12. Now, how might you deal with the tangent and the cotangent? Well, it doesn't really matter which one you pick first, but if I just focus on the tangent, I know that tangent is sine divided by cosine. So I'll just write that out. Okay, if you multiply by the reciprocal, the 13s will cancel out, and that's going to be negative 5/12. So that's your tangent value. And now that you know the tangent, the cotangent is just the reciprocal of that, so negative 12/5. Okay, so just a basic application to your reciprocal trig functions and unit circle, of course. All right, why don't you pause this one, give it a shot. So you were given the secant is equal to 3/2. Okay, so I can fill that one in. Secant is 3/2. And right away, if I know the secant, I know the cosine because they are reciprocals. Okay, so that's, again, kind of a nice freebie. The sine is less than 0. Okay, so I'm just going to say, in other words, the sine is going to be negative. So I know this is going to be negative, which means the cosecant is going to be negative. So you can make some decisions. If the secant and cosine are positive and the sine is negative, think about what quadrant you're in. If cosine is positive, sine is negative, I have to be in the 4th quadrant, right? Because that's where cosine is positive and sine is negative. So that being said, you could actually just take your skills back to geometry. You could go into the 4th quadrant, draw your, that's kind of a lousy right triangle there. And I know that now I know, I'll probably just focus on the cosine over here. Cosine is equal to 2/3. Well, from my origin, cosine is adjacent over hypotenuse. So I place my 2/3 appropriately. Use the Pythagorean theorem to figure out what my missing side is. So that's going to be square root of 5 plus or minus but because it's going down, it's a minus square root of 5. Okay, that's option 1, which I think some of you are going to prefer. Well, now I can use that triangle to find everything. So if I go back to my theta here at the origin, sine is opposite over hypotenuse. Opposite is negative square root of 5. Hypotenuse is 3. So negative square root of 5 over 3. I can just use this triangle for absolutely everything. Cosecant is the reciprocal of sine, so that's going to be negative 3 over the square root of 5. Then you have to rationalize that denominator. So multiply by root 5 over root 5. So that's negative 3 root 5 over 5. So a little bit of simplifying. Okay, go back to your triangle and find the tangent. Well, from theta, tangent is opposite over adjacent. So that's going to be negative square root of 5 opposite over adjacent, which is 2. Reciprocal that to get your cotangent, so negative 2 over root 5, and you
Nathan Friesner, please call 58021.
gotta rationalize that one as well to get your cotangent. Okay, option 2, which I'm not gonna full out do, but you can use the fact that your unit circle is x squared plus y squared equals 1. I'm gonna go back to, originally all I knew was these two pieces. So if I know the cosine, I can find the sine. Because cosine is x, and I'll just show you briefly this one side. X squared plus y squared equals 1. I know my cosine is x, so that would be 2/3 squared, and then from there, you can figure out y. And y is sine, and once you know sine, you know cosecant, and if you know cosine and sine, you can use those ratios to find tangent. Okay, so we kind of did something like that in this previous example. So you have options, which honestly is what makes some of this hard. All right, gonna end with trig identities. You don't need to memorize all of these, so I'm gonna give you a second to look over these. I'm gonna briefly talk about them. Okay, I already talked about the reciprocal identities, but I was using x's and y's. So you know cosecant and sine are the reciprocals of one another. So I could write that as sine equals 1 over cosecant as well. Secant and cosine are reciprocals, cotangent and tangent are reciprocals. Okay, we already covered those. Tangent is the ratio of sine divided by cosine, which means cotangent is the opposite, right? Reciprocal, cosine over sine. Pythagorean identities is what I did not talk about, but I will remind you that we did talk about x squared plus y squared equals 1, and you know that x is cosine and y is sine. So that should be familiar. Okay, that's where, that's all it stems from. Now, if I come over here and divide everything by sine squared, because that's legal as long as I do everything by sine squared, well, what is sine squared over sine squared? It's 1. What is cosine squared over sine squared? Cosine over sine is cotangent. If I square both of them, that's cotangent squared. And what is 1 over sine squared? Well, if 1 over sine is cosecant, 1 over sine squared is cosecant squared. And that's where that stems from. Same idea, and I won't go through that again, but if I divided everything by cosine squared instead, then I will get this middle one. Okay, so that's where the Pythagorean identities come from. But again, you don't need to memorize these, so just write them down, take a picture of this, whatever you want to do. Here's what you're going to use them for. Okay, so you're going to be asked to write tangent in terms of cosine, and cosine of t, and t, the angle, needs to be in quadrant 3. So remember how I said this means something, it's a big deal. Okay, so quadrant 3, obviously over here, where cosine is going to be negative, as will sine be. Okay, so just keep that in mind as we do our work. So tangent in terms of means your expression can only have cosines. In terms of something means just that. So tangent, maybe the obvious first step is to write that as sine of t over cosine of t, okay, from the tangent ratio. I want tangent to be in terms of cosine. Well, right now it's in terms of sine and cosine. So this is good, this sine, not good. Obviously it's not cosine. Okay, so now I need to go up to my tools above and find a trig sine that I could rewrite in terms of cosine. So if you look at all of these, the only ones that connect sine and cosine and nothing else is this Pythagorean identity. It has sine and cosine and 1. 1 is totally fine. Okay, like you can have numbers. I should probably clarify that. So, I'm just going to erase these so it's not confusing. So if I sidebar sine squared plus cosine squared equals 1, if I solve that for sine, it will stick with t's. I'm going to subtract over the cosine squared. And then to solve for sine, I would square root both sides, right? Okay, now here is the part where I would plus or minus. In fact, I will plus or minus, and then we'll stop and talk about which one I'm going to use. So here is where the quadrant is important. It doesn't matter that where the tangent is in quadrant 3. It doesn't matter where cosine is in tangent 3. It matters where sine is. Oops, I didn't want to square it here, sorry. It matters what the sign of sine is in quadrant 3, because that's what I just solved for when I plus or minused. Okay, so this right here is what I'm going to base my decision on when I pick my plus or minus. So in quadrant 3, sine is negative, so I want the negative answer of my plus or minus. That is confusing for many, so take your time because there's so many trig functions here to base your plus or minus decision on. Okay, but based on this, if my sine is this expression, now I can go back up and replace this sine with that expression. So instead of sine of t, I would have a negative square root of 1 minus cosine squared over cosine of t. This right here is tangent in terms of cosine. And that's about as bad as it's going to get right now. Okay, one more on that just so that you can get another example. Okay, so write the first expression in terms of the second. So I'm going to write the blue in terms of the red. So again, in terms of cosine. So if you think about secant is the reciprocal of cosine, so probably a good place to start is this is cosine squared. Okay, again, keeping in mind I'm trying to get everything in terms of cosines. So I'm halfway there. Now sine squared is not in terms of cosine, but this one's kind of nice. I can, again, use this Pythagorean identity to rewrite sine squared t if I subtract over the cosine. Rewrite sine in terms of cosine. So now, substitution, I have 1 over cosine squared times 1 minus cosine squared from my Pythagorean identity, and everything is in terms of cosines. And it doesn't matter if they're squared or not squared, the ones are fine. You really could leave it as is. If you want to distribute that through, you could also have 1 over cosine squared minus 1. Either of these are fine answers. So that is secant squared times sine squared in terms of cosine. Whew. All right, last but not least, and this is the easiest part of the whole lesson, is you will need to know how to type in basic angles on your calculator. So I have the TI-84 screenshot here. This is the TI-89. You need to check your mode, and you always need to be checking your mode. If you evaluate an angle in degrees, you want to be in degrees. If you evaluate an angle in radians, you want to be in radians. So you go to your mode button. Okay, so you really want to take a second and find that. It's pretty obvious, one of your main keys. So when you go to mode, you'll see this picture. Okay, 84s, notice right here, you have the option between radian or degree. And 89s, I showed the drop down, it says angle, and you're gonna get this drop down, and you'll have radian or degree. Don't worry about gradient. Okay, so you have to be conscientious. So if you look at my example, I have cosecant of 37 right here. Is there a degree symbol? No. No degree symbol. This is in radians. Okay, cotangent of 1.7, no degree symbol. This is radians. If you don't see a literal degree symbol, then it's in radians. The other thing I just wanted to make sure you were careful of when you type this into your calculator, cosecant, you don't have a cosecant button, but you do have a sine button on your calculator. So cosecant is the reciprocal of sine. So you reciprocal your trig function, but not the angle. Don't do 1/37. You do 1/sine of 37. And same with cotangent, it's the reciprocal of tangent. So you don't flip the angle, you just flip the trig function. Phew, okay. So we're done. Take a deep breath. I hope you are so excited about trigonometry because it is my absolute favorite. And that's what all of chapter 5, 6, and 7 is on. Have a wonderful day.